I said put it in the trunk. The trunk. Oh, hi. All right, I hope at this point you have launched the virtual lab and you're waiting for it to load right on the link on the website. And let's walk through what this lab entails. The aim of this lab is to ensure that you feel comfortable configuring VLANs, trunks, and VTP across a mid-size organization. As usual, no show run commands will be allowed in this. Just want to make that disclaimer from the beginning because that's cheating. And a lot of times, a lot of the situations, you'll actually be restricted from using show run on a certification exam environment. So we've done the same thing. But also know that in the real world, you'll often use that as one of your key commands for troubleshooting. So I want to make sure you know that it's not cheating to use that really, right? So first and foremost, we're going to look at the Arizona switches, determine which interfaces are existing trunk ports, looking at these. We need to configure every trunk port to use a modern trunk encapsulation. We'll talk about what that means and ensure the trunk does not dynamically become an access port. Second, we'll determine the current VTP mode on all Arizona switches and create 4 different VLANs. Names right in the parentheticals on each one of the switches and verify that they did or did not appear on all the other switches and figure out why or why not that might happen. Then we'll convert all the switches to VTP transparent and throttle the trunks in Arizona to only carry VLANs 1, 10, and 11. VLANs 30 and 40 will not be used in this exercise. All right, so that is the VLAN trunking lab. Now, in one of the VLAN skills that I was walking through, I kind of just went for it. I went beyond base VLANs, I went beyond base trunking, and I set up a router on a stick. So I'm going to say if you're feeling comfortable and you just want some bonus exercise time, I actually added the router in Arizona as one of the available devices. And I want you to configure that guy as a router on a stick using the knowledge that you've got so far to provide routing between clients in VLANs 10 and 20, and then we'll ping and verify that we actually do have communication between those 2 clients, right? Now that is bonus. There's actually a whole other skill on configuring routing, router on a stick. So if you just want to wait till then and do it, right. Okay, so let's get going. So, whoa, wait a second. This is where you pause. What I was just about to go through the walkthrough. So please pause right now. Here, I'll put the screen right up here. I'll start erasing all my chicken scratch off the screen. Hit the pause button and try this one yourself, making sure that you struggle through this. It's good to struggle. It's good to get stuck. Or maybe you just go right through and you're like, I'm a Cisco master. That's totally fine. Regardless, I would like you to try and then unpause and we'll go through it together. You ready? So pause now, right? Right there. Pause now. Okay, I'm going to assume you paused, and now let's do the walkthrough. So first off, on the Arizona switches, let's determine which interfaces are trunk ports. The easiest way to do that is by typing in show interface trunk. And that will outline, and this is from the access switch perspective, GI 0/1 and GI 0/2 are trunk ports. So that'd be right there. And right there, my red coloring is blending right in there, right? Okay, so let's look at core 1 and core 2. Show interface trunk, and I can see 0, 2, and 3 are trunk ports. And let's just verify. We've got 0, 2, and 3 are trunks, and I have a feeling, just guessing, looking at core 2. Let's do a show interface trunk. And I can see right there that 0, 1, and 2 are also trunk ports on that guy, which is 0, 1, and 2. So all of these between the switches have negotiated a trunk port. So, okay, so let's just, and I said the word negotiate. I kind of gave away some of that. It says configure every trunk to use a modern trunk encapsulation. Well, the question is, what trunk encapsulation are they using right now? And how do we figure that out if there's no show run command? Well, that's where we would go to the show interface. So I'll just pick one of them, gigabit 0/1, switch port, key command for VLANs. I can see right there, the mode is dynamic desirable. So all these ports are set to auto negotiate, which is why they automatically negotiated trunks, is because if all of these, let me just grab my pen, if all of this, DD, DD, if they're all dynamic desirable, then they all desire to be trunks. They're trying to negotiate that. So they, poof, will become a trunk operationally speaking. You can see that right there. And you notice right here, the operational trunk encapsulation is what? ISL. Whoa. Let's go gigabit 0/2 switch port. That one's also trunk, also ISL. Okay, so you remember there are two different trunk encapsulations. A really old one, the one that Cisco came out with originally, just fly by history lesson. 802.1q was originally released and it was really bad, really inefficient. Cisco improved it and made a proprietary ISL because why would you use any other switch but Cisco? So ISL became a dominant trunking force until they updated 802.1q to be better. So it was better than ISL. So ISL should have faded away. It just took a long time to do that. So we'll go into global config mode. Let's do interface range GI 0/1 through 2. And again, what am I doing here? I'm ensuring every trunk uses a modern trunk encapsulation. Oh, might as well while we're here. Ensure the trunk does not dynamically become an access port. So that would mean to me that we need to change this administrative mode from dynamic desirable straight over to a trunk, because this will become an access port if you plug in an end device, right? So I'll say switch interface range, and then I'll do what is it? Switch port trunk encapsulation, and we have our two options: ISL or 802.1q. So I'll put .1q. Boom, that's configured. Switch port mode trunk. So this by the way, and notice it went down. That's because the other side is ISL. I'm going to say this guy is going to be a trunk, reset the interface. So now we're statically configured on this. Now let's head over here and do the same thing. We'll go into interface. I'll just do interface GI 1/0, switch port mode. Well, let's do switch. If you do switch port, if you've got... I'm trying to say like 50 things at once. If you've got a switch that supports multiple trunk encapsulations, when you do switch port mode trunk, it'll balk at you. It'll say, no, you can't do that until you statically set switch port trunk encapsulation .1q. Then it will take that command just fine. We'll also do interface range GI 1/2 through 3. At the up arrow, switch port mode, let's do encapsulation and switch port mode trunk. Get that guy configured and going. Good. And lastly, core 2. We should have all those trunk interfaces up there. We'll do interface range GI 2/0 through 2. That's all of them. Switch port trunk encapsulation .1q. What is that from? Lego movie. I just saw that not too long ago with my kids where, what is it like? Rex, Forest Explorer. Anyway, .1q, switch port mode trunk. And there we go. So we'll do, and that's all of them, right? So now we should be able to check all of them. I'll do a show interface GI 0/1 switch port. There we go. Administratively trunk, operationally trunk, administratively .1q, operationally .1q. That's so administrative is what did you set it to, operational is what did it negotiate. These will be different if you use any kind of dynamic mode whatsoever. So bam, that was a big step. All Arizona switches, we've got hard-coded trunks going all the way across right here. Sweet. Now, determine the VTP mode on all Arizona switches. Okay, let's do that. We'll come back here. Show VTP status is our VTP command. I can see that it is running version 2. Its domain is cbt.com, and it's operating. Yeah, there it is. It's a server. Okay. Show VTP status. It's a server. Okay. Show VTP status. It says server. They're all servers. By the way, that's the default mode of VTP. Okay, so coming back here, what do we do from there? We're going to create VLAN 10, 20, 30, and 40 on one of these switches. Okay, and we've got the names right after it. So I'm on core 2 right now, so I might as well use that one. Conf-T. So let's do conf-T. We'll do VLAN 10, name server. Okay, exit back out. VLAN 20. name, VoIP, exit back out. Let's go back to VLAN 30, VLAN 30, name client, exit out, VLAN 40, name public. Sweet. Come back here and we will do a show VLAN. Verify, yep, those are all there. Okay, good. We've got those created. So create the VLANs on one of the switches. Did the VLANs appear on the other switches? I don't know. Let's look. Core 1, show VLAN. Oh, access 1, show VLAN. Oh, what is going on here? What is amiss? Why did they appear on all of these different switches? Well, the reason why is because we are using VTP, and VTP will automatically replicate VLAN. I mean, if we scroll back up, you can see right here we had 5 VLANs before. We went out on core 2 over here, created some VLANs, and notice it's like, whoop, okay, number of VLANs are 9, and it did that. It kept everything in sync by incrementing that configuration revision. Notice, hang on, right here before we created the VLANs, it was config rev 18. Down here, config rev 22. So VTP database is incrementing that. So the answer to the question on why or why not is because of VTP replication, since these are all servers. Okay, we don't want that because, in most cases, we want to control where our VLANs go. We don't want any kind of disaster to happen. So I'm going to go to each switch into global config mode and do VTP mode transparent. You can see it sets it as transparent. I'll do a show VTP status and verify, yep, config rev is reset to 0. It is now a transparent mode switch, so it is no longer participating in that. Cool. So we'll come in here, VTP mode transparent, bail out on that. And last one here, global config VTP mode transparent. And we are good. Now, we'll still keep its VLANs. It keeps the ones that were replicated. It's just no longer going to participate in any kind of VLAN replication whatsoever. It will pass, by the way, you might be handy to know this. If you've got, okay, so scenario, switch, right? VTP servers, and there's a VTP transparent switch in the middle of them. They're not directly connected. Replication can actually pass through the transparent switch, and these two can update each other. The VTP transparent switch just ignores that, right? Kind of a fun fact for you. Okay, so good. Okay, back to the lab. We've got that done. Okay, cool. Now limit all trunks in Arizona to only carry VLANs 1, 10, and 20. VLAN 30 and 40 won't be used. Okay, so back here, I'm going to go to access 1. Show interface trunk, because I want to see those in front of me. I'll go to interface range GI 0/1 through 2, and we'll do switch port trunk allowed VLANs. And notice you have the option of typing in which ones you want to allow, or you can add some or remove some. In this case, I just want to say I only want to allow 1, 2, not M, 10, and 20. Enter. Good. Bail out there, and then we'll come right here. We'll do the show interface trunk here. Global config interface range. I always forget. You can do this. You could do 1/0, comma GI 1/ I think it's 2 through 3. Well, let me do that all at once. Yeah. I always forget. It's finicky, right, with that syntax. Okay, so that'll do all of them at the same time. Switch port trunk allowed VLAN. And 1, 10, 20. Enter. By the way, great way to verify this is using that same show interface trunk command. And you'll be able to see which ones are actually allowed. You notice up here, it was all of them. Now it's just the ones that we specified. One more. Show interface trunk so I can see which ports. And we will go in and do interface range GI 2/0 through 2. Switch port trunk allowed VLAN at, almost did it. 1, 10, and 20. If I would have said add, but that's the one you normally use if you're just going to add a VLAN. It would do what I typed, but it wouldn't remove these guys. By not having the add on there, it says only those ones are allowed. So if I come back and do that show interface trunk, I can see whoosh, throttled back down. Sweet. So I think we're done with the required objectives. Let's look. All of that is complete. You have completed your trunking lab. Now, if you'd like, if you want to, because I really want to, let's go on and configure a router on a stick, right? Let's get that guy going and see if we can get some routing going on. And again, this was bonus. It wasn't part of the official, like, this is trunking, but it's so fun. So fun. So where's my button? There we go. So let's configure router 1 in Arizona as a router on a stick. So first and foremost, I need to make sure if I'm going to do this, this is going to be a trunk as well. And I'm not sure that we included that guy in all of our configurations. So let's go back to core 1, right? Core 1. Yep. Core 1 is the one connected. And I'm going to go into interface GI1/1. And let's go all out. This is going to be switchport trunk encapsulation .1Q, switchport mode trunk, 5, switchport trunk allowed VLAN 1, 10, and 20. We'll restrict it even down to that router, right? So then I'll go in and do a show interface trunk. We reset the interface. And good. It has added itself to our little minions here of trunk ports. Okay, cool. Now let's head over to router 1 Arizona. Let's do a show IP interface brief because we're going to set this guy up as a router. Hang on, router. That's very enunciated. I'm going to come right here and it's port 0/0 is plugged in here, but we haven't done anything here yet in terms of VLAN. So what I'm going to do is I'm going to remove, and you may or may not have done this if you tried it, I'm going to remove the IP address from this interface because we're moving off of VLAN 1, and that's going to be what our native VLAN is, our VLAN between those two. And I'm going to add the .10 and .20 interfaces as a gateway for those guys and set up routing between them. Cool? Let's do it. Global config mode, interface GI 0/0, no IP address. By the way, CBT Nuggets supports slow motion. I don't know if you found this. There's some people, they were like, oh, I listen to you at 2x speed all the time. I'm like, what's wrong with you? I can't even hear myself at 2x speed, much less somebody else here. So if you need to slow it down, feel free. Exit back out, interface GI 0/0.10. We'll do, what is it? Encapsulation .1Q10. IP address will be 10.16.0.1. That, and I'm going to assume because it's not explicitly stated in this lab that that's what the gateway is, but I'm going to assume that's what it is. IP address 10.16.0.1 255.255.255.0. Good. And we'll go into interface GI 0/0.20. Trunk encapsulation .1Q20, so it responds to tags for VLAN 20. And where's my IP address? There. And 2.1. So we will go change this from 0 to 2.1. Sweet. Let's do a show IP interface brief. Good. Now what I'm gonna do before I actually test using the ping between PC 10 and PC 20, that's our test. I'm actually going to just make sure this guy can ping this guy and this guy can ping this guy, because if something's wrong there, then obviously these guys are not going to be able to ping between each other. So let's go back here and I'm going to do ping 10.16.0.10. That's not good. That's not good. That's not good. That's not good. Ooh, wait a sec. We did trunks. Ooh, I bet. Oh, I hope some of you went into this and got stuck here, because I'm not masochistic, right? I'm not like, I like your pain. I don't think. But what I'm excited about is I want you to get stuck so that you're like, I don't know what's, and maybe you, I don't even know. Maybe you figured this out. I kind of create these labs without really figuring out what's going on. So let's see. Okay, so I bet you those PCs. Let's do a show VLAN. Show VLAN. Show VLAN. We don't have them assigned to the right VLANs. Of course, we created the VLANs, right? So hang on. Port 0/0 should be in VLAN 10. 1/0 should be in VLAN 20. Okay. So let's go in. I know somebody right now is like, oh, are you kidding me? Yep. So interface G0/0, switch port mode access, switch port access, VLAN 10. Sorry, sometimes I just go crazy on my shortcuts. Those are real words. Interface 1/0, GI 1/0, switch port mode access, switch port access, VLAN 20. And now we wait. What do we wait for, Jeremy? We wait for spanning tree. I'm going to do a show spanning tree VLAN 10, and you can see it's going to take about 30 seconds for that to go active. Same thing with VLAN 20. We've got our guy sitting in there. He's still in the blocking state. So we'll just give him some time. I mean, I could cut this out, or I could be like, yeah. Well, I'll cut this out. All right, I think it's done. So let's go back. Hit the up arrow. Let's do show spanning tree, and yep, we are now in a forwarding state. Okay, now let's come back here and hit the up arrow. And jury says success. Oh man, that first little dot, I'm like, something else is wrong. Okay, so let's go right here and do 2.10. Is it 10? Is it 10? Yeah, it's 10. 2.10. And success. Great. Okay, so now let's go over to client PC. And we only have access to one of them, P A $W0RD. This is going to be PC 10. And let's log in here, CMD, ipconfig. This is the .10, so let's ping 10.16.2.10. That's PC 20, right? Oh man, really? No. Yes? No. All right. Let's see if we can ping 10.16.0.1. Okay, that's weird. Why would that happen? Whoa, it just responded. Did you see that? It was like it was timing out, and then bam, it responded. Okay, so okay. let's just say that's part of labs and using simulated equipment, which is so let's do this. Let's do a trace RT -D, which doesn't resolve hostname, just makes it go faster. 10.16.2.10, and we should see, yep, going through that router and then reaching over here to this guy on the other side. Now, we don't have access to PC 20 over there, but we can verify our router on a stick is successfully routing packets between them to the other side. That is so good. This is so good. So at this point, I think we are done. We did everything in here and the bonus. And I hope this has been informative for you. And I'd like to thank you for viewing.